Hi all, welcome to LearnCodeRepeat. So today we'll be looking at day 23 of the October LeetCode challenge. The name of the problem is 132 pattern. Let's look into the problem. So the problem states given an array of n integers nums, a 132 pattern is a subsequence of 3 integers num of I, num of j and num of k such that I is less than j which is less than k, and the nums of I is less than nums of k is less than nums of j. Return true if there is a 132 pattern in nums, otherwise return false. Follow up, the O of n square is trivial. Could you come up with the O of n log n or O of n solution? And they have given a couple of examples. So let's take the second example here. So here it is 3142 and the output expected is either true or false. So here if you see 1 is less than 4 and 2 is less than 4 but it is greater than 1, right? So if this is I, j and k, right? This is I, this j and this k, right? So nums of I should be less than nums of k and nums of k should be less than nums of j. So the in between should be higher. So if it is a graph something like this, right, where the numbers are going up, so this will be like going up and then it is going down. So 4 is here, 1 is here and 2 is here. Okay, so we have to identify such patterns, and this pattern need not be contiguous, it is a subsequence, so there can be a gap in between. So it can be like 3 comma 1 comma 4 comma 5 and then 2. So here 1, 4 and 2 is correct even in this case. Okay, so let's see how we can solve this first using a brute force approach and then we can optimize the solution. So one of the example is -1320. So we have to find three numbers, right, I, j and k, right, such that nums of I is less than nums of k which is less than nums of j, right, and I is less than j is less than k. Okay, so these are the condition, right. So the simple approach will be to use 3 for loops and go through I, j and k nested loops and find out this condition, right, whether this condition is true then return true, right, and the algorithm will look something like this. So we have 3 for loops, 1, 2 and this is the third one, and we can check inside the nested loop, the innermost loop, whether the conditions are met then return true. This is a simple brute force approach, right. However, for this, since it is nested 3 for loop, the complexity will be O of n cube, right, where n is the number of elements in the array. Okay, and we are using no additional space here. So the space complexity, so this is the time complexity and space complexity will be O of 1 because there is no additional space used. Now can we improve this particular algorithm, right? So here, right, instead of having one for loop, right, so we have nums of I, nums of k and nums of j, right. So 1 I can say 1 is the min value, so this is the minimum value, and then there is a middle value and then there is a max value, right. So I can identify min value and I can keep that min value as is, right. So let us say this is the array, right. So I can check what is the min till that point and I can keep that min value as is, right, because they are asking for any combination, right. If there is any combination that satisfy this condition then we are good, we should return true, right. So if the minimum value till a given point, right, till a given index should be okay for us, right. So what we can do is we can remove this, right, this particular for loop, we can remove this, and within this j for loop, right, we can just check what is the minimum till that point and use that min of I, right, let us call that as min of I, to replace this particular nums of I, right. So the algorithm for that will look something like this. We are using min of I which points to nums of 0, then for each j iteration we are checking what is the min of I till that point. So it is a mat dot min of I and nums of j, the current element, and then inside the for loop, so we are checking the same condition, right, nums of k is less than nums of j and min of I is less than nums of. So by doing that we have optimized the algorithm to O of n square. Okay, now can we further optimize this, right, can we further optimize this to O of n, and that is what they are asking in the question, can we optimize this to O of n. So the first thing that we can see here, right, we can have a separate for loop for this, right, to calculate the min value, right. So let us say if I have a separate for loop to calculate a min value, then in that case I need to store that min value, right. One thing I can do is have a min nums array, and at each index, right, we need to find out what is the minimum till that index, right. So if I am at this index, what is the minimum till that index? So here it is -1, if I am here it is again -1, right, and for this particular case everything will be -1 because till each index the minimum is -1, right. So that way I can form the min array, right. So I will need one for loop for the min array. So till now the time complexity is O of n, right. Now I need to check whether that condition is satisfied. What was that condition? Nums of, so the condition was nums of I is less than nums of k, which is less than nums of j, and I is less than j is less than k. This was the condition, right. So let me highlight this here, right. So we will check how can we use one for loop for this condition, right. So one way we can do is we can go from right to left direction. So let us see how it will help, right. So if I am using a for loop to go from right to left, right, let us say this is k equal to num, let us say nums is n dot length minus 1, and k is greater than or equal to 0, k is minus minus, okay. So this is one for loop. So we just need to use one for loop to solve this equation, right, or to solve this problem, right. So how can we use one for loop, right. So what we can check is, since we have the min nums value, right, so min nums is nothing but this nums of I condition, right, that we are replacing with min nums. So here I can check whether my nums of k is greater than nums of I, right, which is min num. So if my, let us say n is the nums of k, right, I am just using n here, n of k, if it is greater than min nums of k, okay. So what this means is I am going from here, that means there is some min value which is less than my n of k, my nums of k, okay. Now we do not need what exactly is the min value, right, we just want to check whether this condition is satisfied. So any min value is fine for us. So here we can very well say that j is less than k, right. So we need one k and one, either k minus 1 or 2 or 3, whatever is the value, right, that should be satisfying this particular case, right. So first we are checking for this nums of k is greater than nums of j. So we have taken care of this particular two condition, right. Now how can we take care of this two condition, okay. So what we can do is, first we can add the number that we are getting in a stack, right. So let us say this is a stack, right, I add this value 0, right. Now in the next iteration, if this condition is satisfied, that means my next number, that is here 2 is greater than min nums of k, min nums of k is -1, which is true. If that is satisfied, so I can directly check in my stack, and I can, so here I can check my stack is not is empty, and I can check whether my stack's peak, right, that is the top of the stack, if it is less than my min value, if it is less than or equal to, then pop it, okay. So stack dot peak is less than or equal to min, then I need to do a stack dot pop. Why I need to pop it? Because if it is less than or equal to min, right, then it will never satisfy this condition. Even if I move forward, right, on the left side, it will never satisfy this condition. So I can very well pop that element from the stack, okay. And after that, if there is still any element, right, so that means if stack is still not empty, and I can check this condition, right. So this nums of j is my current nums of k, right, here in this case it is, this is my current k value. So this current k value is greater than my nums of k, right, which is the element in the stack, stack dot peak, okay. So that means I am somewhere here 2, so this needs to be greater than this, right, that is what it is, right. So if k is greater than j, so this k is this value, right, which was the value in the stack, right. and my current pointer is to this 2 pointer, right, or 2 index, right, which is nothing but the j value. So j value is here, since I am using one for loop, so I am using the variable as k here, but this is basically, in this particular case, it is the j value. So I am checking that condition, nums of j is greater than st dot peak, which is the stack dot peak. So stack dot peak has nums of k value, which was this. If that is the case, then I can directly return true, right, because now it has satisfied this condition and this condition was satisfied in the if condition here. If that is not the case, right, then we can very well use this nums of k for the next iteration. So I can directly do a stack dot push my nums of k. Okay. So using this one for loop, now I can solve this problem, right. So let us say what will happen in this case. So in this case, anyway it was only 0, so it will be popped up, right. So let me remove this and add another condition. So let us say the input is 1 2 3 4, right, this is the input. So the min array will be 1 comma 1 comma 1 comma 1, right, because 1 is the minimum value. And when I am going through this for loop, right, initially my stack, right, my stack will be something like this. So initially it will be 4, right, 4 will be added, this 4 will be added into the stack, then my pointer will be here. It will check whether this current pointer is greater than min value, yes, the min value is this, yes, and is it greater, that is nums of k, is it greater than the value in my st dot peak, right. So this, my stack will not be popped, okay. So it will check whether this is my current pointer value is less than min value, yes, so if condition is satisfied. Now it will check in the while loop whether stack dot peak is less than min. So stack dot peak is 4, 4 is not less than min, so this while condition will not be executed. In the if condition, it will check whether nums of k, which is 3, is greater than stack dot peak, 3 is greater than 4, no. So it will go to this, it will push my this number 3 into the stack, okay. Now my pointer will be here, it will check whether this is greater than min value, yes. It will again check whether this is greater than my stack, no. So this will be added here, and similarly 1, it will check whether 1 is greater than min, no. So it won't even go in this if condition. So final value in the stack will be 2 3 4, and at the end the for loop will exit. So at the end, if the for loop exits, we can directly return false here, because we know there won't be any condition that satisfies this particular case, right. So let us code this and see whether it works fine. So here I have written the same algorithm. So first I am checking whether the length is less than 3, then I can directly return false, because I cannot check the 3 conditions. So that will be my base case. Then I am creating a min array, min nums array, and I am storing the minimum value till that point using math.min. And then this is the one for loop that we are having. In that, first I am checking if my current j is greater than min nums of j. Only in that case I will enter in this particular if condition, and then I am checking in the stack whether stack peak is less than min nums. If that is the case, then pop the stack, and after doing the while loop of popping the stack, I am checking if still there exists an element in the stack which is less than nums of j. In that case, the condition is satisfied, so we have to return true, else add the element into the stack, okay. And at the end we are returning false. So let's run this code and see whether it works fine. And the code is accepted. So here the time complexity is O of n, since we are using only 2 for loops, it is not a nested for loop, there are 2 for loops, so it is O of n. And the space complexity is also O of n, because we are using a min nums array and also a stack, so both will take max O of n space. So space complexity is also O of n. So that's it for this video. Thank you.